Now let's take a look at problems 3 and 4. So for problems 3, we're going to try to factor both that numerator and the denominator. Well, there's nothing I can do to factor that numerator, right? There's nothing that multiplies to negative 10 and adds to 1. So we're going to just move ahead and we're going to go find that vertical asymptote. So for my vertical asymptote, remember we set my denominator equal to 0. And so that gives me x equals negative 1. So we will go ahead and sketch that. There's my vertical asymptote. Next, we'll go ahead and find our horizontal asymptote. Well, this time around, we have a power of 2 in the numerator and a power of 1 in the denominator. That means that the power is higher in the numerator. So there is no horizontal asymptote, but instead, we have a slant asymptote or an oblique asymptote. So how do I find that? Well, if you recall up in the notes, we have to use synthetic or long division, and I literally divide the numerator by my denominator. In this case, I can use synthetic division because I'm dividing by x plus 1, a binomial with a power of 1. So I'm going to use that. So I take a negative 1 out front, and then I use my coefficients of 2, 1, and negative 5. When I do that, I bring down my 2. Negative 1 times 2 is negative 2. That gives me negative 1. Negative 1 times 1 is 1. That gives me negative 4. When I do my synthetic division or long division, whichever you choose, what your result is going to be your equation. Now, the equation is simply going to be y equals mx plus b. So we will ignore the remainder. And then we will use the 2 as my x term and the negative 1 as my constant. So my equation will be for the oblique asymptote, y equals 2x minus 1. Okay, so again, my vertical asymptote is x equals negative 1, and my oblique or slant asymptote will be the equation of y equals 2x minus 1. We ignore that remainder. So now we'll sketch that. 2x minus 1 means we start at negative 1, and then we go up 2 over 1. 2 over 1, up 2 over 1, or down 2 over 1, down 2 over 1. And I'll go ahead and sketch that. Again, remember it's an asymptote, so I'm just going to use a dashed curve. All right, so a little bit different from the others because I have a slant here instead of a horizontal asymptote. However, to find my curves, I'm still going to base it around that vertical asymptote. So we know at negative 1, it's undefined. So I'll test negative 2 and negative 3 and 0 and 1. And we'll plug those values right on into my equation. Okay, so if I plug in a 0, let's start with that because that's nice and easy. If I plug in a 0 to the top, I get negative 5 and I get 1 on the bottom. So negative 5 over 1 is negative 5. If I plug in a 1, we would have 2 plus 1 is 3. 3 minus 5 is negative 2. So negative 2 in my numerator over 1 plus 1 is 2. So I get negative 1. Now if I plug in negative 2, we would have negative 2 squared, which is 4. 4 times 2 is 8. Then we would have 8 minus 2 and then minus 5, which gives me positive 1. Now if I plug in negative 3, I plug that into the top, I would have 9 times 2 is 18. 18 minus 3 minus 5 gives me 10. And then on the bottom, I would have negative 3 plus 1, which is negative 2. So I would have negative 5. Which I just want to double check a sign. Negative 3, negative 5, negative 2, 1. Okay, that's okay. 0. Okay, I think we're in good shape. So now I will sketch those points. Negative 3, negative 5 is here. negative 2, 1 is here. And so as we can see here, we're going to approach those asymptotes, and then it curves. So there's my first curve. And then we'll have 0, negative 5, and 1, negative 1. And same deal, we'll approach those asymptotes and curve. So not as sharp of curves as the one before, but we still have curves. And there's your graph for number 3. Okay, again, slant asymptote because the power is higher in the numerator than it is in the denominator. All right, last but not least, let's take a look at number 4. So for number 4, we're going to see if we can always factor first, right? So in my numerator, what multiplies to 1 adds to 2. We have x plus 1 and x plus 1. And then in my denominator, what multiplies to 2 and adds to 3, that would be x plus 2 and x plus 1. So that's important for finding our vertical asymptotes. Well, if you notice on this one, this time around, we're going to have not only vertical asymptotes, but also a hole. So our hole is going to be where we have these common factors of x plus 1. So I'm going to set x plus 1 equaling to 0, and that gives me x equals negative 1. So that's telling me that there is a hole at x equals negative 1. Again, a hole is when there's a factor that's in common in your numerator and in your denominator. We want to actually find that ordered pair. So to find that ordered pair, I plug it into my new equation. So that would be negative 1 plus 1 all over negative 1 plus 2. So I canceled out the x plus 1s, and I'm plugging in negative 1 into my new equation. This would give me 0 over 1, which is 0. So even more specifically, that hole is at negative 1, 0. Okay? Now let's find my vertical asymptote. I still have a vertical asymptote left. It's the other factor in my denominator, and that's at x plus 2, which gives me x equals negative 2. Now, last but not least, we're going to find our horizontal asymptote. In this case, the powers in the beginning and at the end here, when I simplified, the powers are the same, squared on top and bottom, or once I canceled, to the first and to the first. When the powers are the same, we divide the coefficients. So what I have here is really a 1 and a 1, right? Or here, a 1 and a 1. So 1 divided by 1 simply gives me 1. So that means my horizontal asymptote is at y equals 1. So I'm going to plot those key points right now. We'll have our vertical asymptote at negative 2. Our horizontal asymptote is up at negative 1, or positive 1. And then we have a hole at negative 1, 0. So I'm going to literally put an open circle there. Now we're going to go find all of our test points. So we base it around that vertical asymptote, which was at negative 2. So I'll test, things like negative 1 and 0, and negative 3 and negative 4. And we'll plug those in. Now I'm going to plug them in. It doesn't actually matter whether you plug them into the original or to the new one. I'll just plug it into the new one because that's way less calculations to have to solve. So if I plug in a negative 1, we would get negative 1 plus 1 is 0. And, we actually already found that, right? That was our hole. So we have negative 1, 0. If I plug in a 0, we would have 0 plus 1 is 1, and 0 plus 2 is 2, so I'd get 1/2. If I plug in a negative 3, we'd have negative 3 plus 1 is negative 2, and negative 3 plus 2 is negative 1. So again, that would be saying negative 2 all over negative 1, which is 2. And if I plug in a negative 4, we would have negative 3 all over negative 2, which is 3/2. So -4, 3/2, -3, 2. At -1, we are at 0, and at 0, we're at 1/2. And again, you can make more points if you want, but this is enough because we know we're curves that approach asymptotes but actually never connect. So there's one curve, and then my other curve. Again, we're just not going to go through that hole or through the asymptotes, but we use the hole as a point. And there's my other curve.